Hello, and welcome to TSQL for Beginners. I'm Kendra Little from Redgate Advocate Team, and today in the course, I am here at the site where you can get the scripts that we'll be covering in this video, litkind.github.io/tsql beginners. And if you click on, this week we will be doing the solutions for the challenges for Scalar UDFs. Then we'll be talking about table valued functions, which are awesome. And in terms of using table valued functions, we'll be hitting a new bit, another extra bit of TSQL syntax, right? There's this syntax for table valued functions themselves, but there's also a syntax we're going to cover for cross apply. So the files that we will be covering today are file number 15, the solutions for Scalar UDFs, file number 16, which is the demo. 15 is Scalar User Defined Functions. Scalar User Defined Functions output a single value. 16 is Table Valued Functions, otherwise known as TVFs. Table Valued Functions output, guess what? A table. Of course, there are ways you can write them where you can know that you're going to output a single value too, right? So there's some situations in which we can do one instead of the other, and there are some benefits to that, which we'll talk about. And then there is some challenges for next week, some homework in terms of writing table valued functions. So that's what we're doing this week. Looking ahead, we'll be talking about something totally different. Next time, we'll be introducing windowing functions after, of course, we go over the challenges of this week. And then we will be finishing up with a little introduction to stored procedures in this intro class. So I think all of these topics are really fun that we have remaining. So with that, let's dig into the solutions for Scalar UDFs. All right, so I've actually cloned the repo locally from GitHub. You can clone the repo if you would like to and access them in Azure Data Studio this way. So let's see, we are going to go through the homework via the solutions. The homework is in the solutions. These are the files that we're covering today. So let's see if I can connect to my derp instance. Now, derp, I believe is SQL Server 2016. Let's refresh my memory. Select @ version. If you're ever like, what SQL Server is this? @ version will help you. It's a SQL Server 2017. Come on, you can widen there. The RTM version of that, and I am running the free developer edition. Hey, props to Microsoft for giving us a free developer edition. They don't have to, and not everybody does that. We can even use it on builds and DevOps processes. Yes. Some vendors like to charge for that. I'm not naming any names, Oracle. Anyway, just get that off my chest. So this one, SQL Server 2017, since we're talking about functions, it's also interesting to compare some of the functionality to, I'm going to change this connection to a different instance I have installed. I have named it Seattle. Seattle is the code name for SQL Server 2019. So I have, if I run select @ version here, yes, this is SQL Server 2019. I should probably patch my instances. Also developer edition, right? I should probably be applying cumulative updates to these things. Let's not talk about me. Let's not talk about my failings. Let's pass over this in a moment. So this will allow us to compare. I have wide world importers restored to both instances. So they have added some functions, added some functionality to SQL Server 2019 to improve the performance of functions, which is really interesting, so we can compare. All right, we are going to use the wide world importers database in both of our sessions, and let's get started looking at functions. Now, in the homework, there's a security policy that comes built in with the wide world importers database. It is not a bad thing by any means. However, we're going to be looking at some execution plans today, and it adds things into the execution plans and just makes them harder to compare. So in order to simplify understanding what the queries do without applying a security policy, I am dropping that security policy. So our first challenge here is to script out a function that comes with wide world importers. It's called website calculate customer price. And this is, I talked a little bit last week in the demo about how the reason that scalar user-defined functions have a reputation as being evil. Yes, people who love SQL Server very much have written on the internet about how user-defined functions are evil. Because they cause these row by row operations like a SQL Server has to perform. If you say, I want to run this function in, if I put a scalar UDF in my select clause or in my where clause or in my group by, or maybe in all of them, it will have to run things many, many times. So what we're going to do is just script this out. If we go to wide world importers, go to programmability and functions and scalar valued functions, we are going to just right click there and script it as create. And I like looking at this function because this is just real talk here. You're going to see code like this in the real world. If you go work on SQL code, this is not unusual in the sense of uncommon to find functions in databases that are doing things that are complex in a single bit of code. And the reason people do this is they want to make the code reusable. Right? If you look at everything this has to do, they don't want to have to, write this code 18 times or 100 times or 1,000 times or more than that. They want to put it in one module that they can then reference commonly because it's a complex bit of calculation. It's hard. So if we look at what this does, it takes in a customer ID, a stock item ID, and a pricing date. And then it just does, we're just going to look generally. It looks and figures out, oh, what is this buying group that the customer is in? That's one statement, right? First, we declare a bunch of variables. And then we're figuring out something about a buying group and putting that into a variable. And then we're figuring out something about a unit price based on the stock item ID that's been passed in. And now we're setting an initial value for a calculated price. And then, whoa, we have to figure out something called lowest unit price. And right, look at all this crazy logic in here. And then we've got an if statement. So it's not surprising to me that we would have to evaluate all of these statements, right? And this isn't even the end. It keeps going. It's not surprising to me that SQL Server couldn't always just simplify this logic and suck this into the greater logic of whatever's calling the function, right? This is a lot of separate, discrete calculations doing different variables or doing different operations and storing a lot of things in variables that it then passes on. And then finally, it returns it returns the calculated price after doing heck knows what in here, right? But the benefit of having this in a function is if you have to learn what this does, at least you have one place to sit and stare at this code rather than having the same code in how many different places in your code base and then having to compare them and be like, are they the same? Are they different? Right? So you can see why these things don't perform well, but there's a reason why people use them because life is complicated. There is hope for us, though. There's a lot of hope for us. So there's some cool stuff going on with this. And we have different options sometimes. So we're going to write some queries with that function. And we're going to see how it does. We're going to see how it does on SQL Server. I think I said it was 2017. The important thing is that it's lower than 2019. And then SQL Server 2019. Now, one thing to know about this function, if I take this query, I'm going to copy it. This is our function text. And then on the SQL Server 2019 instance, I'm going to look at some of the dynamic management views. So the magic that we get in SQL Server 2019 is that it can take functions, even some crazy functions, and quote, inline them into the calling query. So instead of having to, for every single row, sometimes more than once for every single row, call a function, depending on where you've referenced the function in the query and how often you've referenced it, right? It can inline these functions. And what inlining means, this concept is also relevant to table valued functions, so inlining is important. What inlining means is that the logic of the function can be pulled out into the calling query itself. So that instead of constantly being like, I got to run that function, for however many rows, maybe 1 million, maybe 10 million, maybe 1 billion, you can just pull the logic in once and maybe not have to do it 10 million times. So this function, website.calculate customer price, it says, oh, it's not inlineable. Now, there's one thing we can change, I believe, to make this inlineable. I'm going to change this connection over to derp Seattle. and I'm going to use wide world importers. Oh, I changed the wrong connection. Hang on. So I want to change, this one needs to be against derp. There we go. So our main demo itself is going to run against SQL Server 2017. This definition of the function, this is the one I'm going to change. I'm going to modify the function on SQL Server 2019. And see how it says here, execute as owner? That's not necessarily a bad thing. That's a security thing that's like, run this in terms of like whoever calls this, the caller, don't run it under their account. Don't run it under their permission set. Run it under the permission set that owns the stored procedure. So I'm going to make a change to this. This isn't something to just do to live code in an application. I just want to show you that this is one of the things that can make a function not inlineable, is not using execute as caller. So if you did make this change, you might have to change other things to not break things. I'm going to now say create or let's just say alter function, right? So I'm going to make that one change in wide world importers over here. And now, if I look at the function, now it is inlineable. So we're going to compare performance for some of the queries we write using this function on 2017, the non-inlineable version, and then the inlineable version. And on 2017, it couldn't become inlineable because they added this feature on 2019. And the modified version on 2019, just for funsies, to see, does it speed up? Like these frankly horrible queries that we have to write. Like the challenges are to write queries that are not pretty queries, but we'll have fun comparing them over there. If you are interested in exactly which things can make something inlineable, by the way, I do have this in, there's a piece of documentation. How did I know? Well, I knew because I looked at the documentation about what things can make a function not inlineable in SQL Server 2019, right? And you can look at that documentation too. All right, so we're going to write a query that uses the website.calculate customer price function in the where clause. So we're going to use 3 tables. We'll be using these in the next questions as well. So we'll build on the joins that you write. We want to return one column, which is the count of rows where this function returns a price greater than 1,000 for a given customer ID, stock item ID, and the date 2016-0401. Because if we look at this function, it takes 3 parameters. It takes a customer ID, a stock item ID, and a pricing date. So we're going to give it a fixed pricing date, a literal for that, but then we're going to use just all the customer IDs and stock item IDs that are in these tables. Now I have a little note here about something I've found about this query, which we could also do that too. I'm not going to have execution plans on first. I'll just do an estimated plan at first. I do need to be in the right database. So we'll just do an estimated plan for that. And we can see, okay, here's the main part of this query, right? Here's where it's actually doing it's scanning lots of large lines here. It thinks it's going to pull a lot of data through. But then also down here, look how many times it's calling these functions, right? It's calling them over and over and over again. But the syntax of our query, let's see if I can get back to the results page there. The syntax of our query, what we're doing is, bump up our font. We've got sales.invoices. Oh, sales.invoices is here. We're joining sales.invoice lines on the invoice ID. And then we're joining sales.customers on the customer ID. We have a criteria in here where we say where website scroll, don't do that scroll, where website, we're putting the function name here in our predicate, where the website.calculated customer price for the customer ID from the customer table, the stock item ID from the invoice line table, and that literal date of the, what's it called? What is that parameter called? That parameter is called the pricing date, is April 1st of 2016. And we want only ones where that's higher than 1,000, and we want to just do a count. So we're doing an aggregate. We're applying a filter. We're joining the tables. So the way this will be processed, we're joining the tables, we're applying a predicate, and then we're aggregating and doing a count there. So if I actually execute this query, Well, it started executing, right? Now, Wide World Importers is a small database. It is actually kind of hard to write a slow query against Wide World Importers simply because the data sizes are so tiny that getting a query that takes 9 seconds is actually a lot of work. Like, you have to make a query really inefficient for it to be slow against Wide World Importers. So if you actually have some sort of challenge that's like, hey, can you write the slowest query against Wide World Importers? Using scalar user defined functions that cannot be inlined is definitely, I would say, one of the good ways to go. So 1061 is what we get there. Okay, what if we copy this query over to SQL Server 2019, where we have made this function inlineable, where the first thing I'll do is look at my estimated plan. And we do still have all these lines going down here, right? Let me make this. Let's see if we can fit a lot of stuff in here. We do still have these lines going down here, but notice that it's actually pulled in bits of query. It's not just like function stuff that's doing, hey, call to function and return. It actually has thought about this more. It's not pretty. I'm not saying it's pretty. I'm not saying I understand all it does, but compared to, let's explain the estimated plan for this one, compared to this one, let's make sure I'm connected to the right. Okay, this is against derp. Let's see if we get a better bet. And now I'm like, I am actually seeing more against this one than I actually thought I would. Hang on, let's make sure I actually have the right thing highlighted. Well, first thing I'm going to do is just start it running. Right? So and I actually didn't pre-time this before the class. I let it be a surprise for me, the behavior on purpose, because the thing I want to show this whether or not it's any faster at all. Because the thing is, okay, this one finished in 11 seconds. The thing is, inlining isn't guaranteed to make anything faster. It might make things faster if it can suck the logic from the function into the plan. It might not, right? So let's make sure. Yes, now it is inlineable. I am going to clear out my procedure cache. This is a test instance. I'm not going to impact everything. I want to make sure, well, no, I recreated the stored procedure, so it's definitely going to have a fresh compile. I didn't need to do that. That was definitely not needed. What is my cost on this execution plan? This is a 1.61547 in SQL Server query bucks. What is my estimated cost over here? 1.5946. So these are different plans. I'm going to rerun this over here to time it, right? So in this, there we go. This is all running, by the way, just against my desktop computer. So there are other things running, like doing the live stream on the desktop computer, but it's not perfectly scientific. So we get 9 seconds against the SQL Server 2017, I think it was, derp instance. And then against SQL Server 2019, I need to, and to be fair, I actually want to, I've run them twice on each one now. To be fair, it should have the data in the buffer pool. There is not a lot of data in Wide World Importers, so I don't really think that's a big factor here, but to be fair. Yeah, so this is 12 seconds on the new one, 9 seconds on the old one, and I feel like that actually was repeatable. So I was curious if this was going to be faster or not. Changing this is not, we'll see for future queries too how they compare too. With the new 2019 feature, I mean, I've heard that it does speed up a lot of things, but it doesn't speed up everything, which makes sense when you think about the complexity of what it's doing, which is, I would say, a minor form of magic. So building on the previous question, this time we want to return only rows, right? This is the same as last time where we have a price greater than 1,000 for these same factors that we had last time. But this time we want to group the rows by the customer name from sales.customer and the customer price using the function. And we want to return not a count, but we're returning different columns. We're returning customer name, customer price, right, using the function to calculate it, and the invoice line count. So this time with these changes, we should get 532 rows because we're not just doing the count. Now we're grouping by customer name, and then we're grouping by the function. So if I start this up executing against the non-inlineable version of the function on the lower version of SQL Server, this took 9 seconds to run. And the syntax we use is, this core middle is the same as from the previous query. We've got the from, the join, and the where. But now we just added on. We added on group by, the customer name, and we can put the function in the group by as well. We then put the function in a third place. We put the function in the select query as well. We're grouping by this. So we are returning the thing we are grouping by, right? We are grouping by the customer price for that date. And then we get the count of the invoice lines. Well, how does this do against SQL Server 2019? I'm curious how this does against SQL Server 2019. Let's go ahead and start this up there. What was our runtime on 20? We had 9.6 seconds against SQL Server 2017. Oh, we got 11.8 seconds here. So that is also slower, right? I wouldn't say that 9 seconds is good for a query against wide world importers. We're going to talk about how to improve these, right? The point is that it's painful. This is how things can go wrong with the function. All right, so this one, what we're going to do here, and there really is a point to, and I've seen this happen in real environments too. There is a point to this whole story with making you use this tortured function to make things slow. So this time what we're going to do is we're using the same like from and joins as the previous query. Right, so we can just copy those down. But now what we want to do is validate. There is a column in the sales.invoice lines table. There is a column named unit price. And what we want to do is compare, okay, let's calculate the unit price using the function. And then let's compare it to the values that are already in that table. In other words, we're already storing unit price in the database. Is every unit price correct when we compare it to the function? If so, if that's the case, the only time we never need to use the function unless we're writing the unit price to that table. In other words, the mistake that I've seen happen is a complicated function like this gets created for the purpose of, okay, let's calculate this and then let's store it in the database. Right? And if you're calculating this for one single row, it's not slow. But then because the function is checked in and there's no code comments in it, other people see the function and they don't realize, oh, I could just read this data from a column in the table. I better use the function to calculate this on the fly for all the rows in this table. And that's incredibly slow. So if you are, let's compare this. What the query does is it say we want to look for rows. We want to join these tables together. And we want to look for rows where the calculated unit price is not equal to the unit price stored in the invoice lines table. And we're going to bring back any IDs for those rows. If we run this query, yes, we do, when we're validating the data, we have to check for every single row. Which, let's get it set up to run against SQL Server 2019. Oh, this one actually, by the way, notice how fast, I think. Oh, it's running, hang on. It returned the first thing again. Yes, is inlineable there. I was made a little nervous by the fact that it didn't return a result. So let's see how long that takes. It returns 0 rows, which is what it should. It took 9 seconds to do the comparison. On SQL Server 2019, we are always slower here. And by the way, this is a very non-scientific comparisons. I haven't I haven't really compared the configuration settings on these instances and all of that stuff. But it's certainly not faster. We got to 12 seconds there. We got to 12 seconds. I am curious. We don't have anything like, and we're not going to get parallelism on this one because, the estimated subtree cost is high enough to potentially get parallelism depending on how my instance set up. But it doesn't decide to do it. This is another thing, and again, this one's getting a little ahead. If you reference a user-defined function, if you reference a function that isn't inlineable, it has to call out to the function for every single row, which is scalar functions before 2019 with exceptions, right? And then certain other kinds of functions. It can't use parallelism in those queries. In other words, you're stuck on one processor, even if the server has a bunch. Being able to inline functions, which applies to table-valued functions as well, gives you the ability to, when SQL Server wants to, use multiple processors, which can help as well. So if that doesn't make any sense to you, don't worry about it. Maybe someday it will matter, and maybe someday it won't matter. But so what this means is, whenever you see a complicated function with a bunch of business logic in it that may be slow, the first question to ask yourself is, potentially, is this function used, or could it be used, to calculate this data for an individual row when it's inserted, updated, or deleted, and it could persist that value in the table? Does anyone actually need to run this function when they select data out? Because there is a chance that in this case, what this function is used for is calculating unit price and then storing it in the table. So you really don't need to use it in your queries unless you want to make sure unit price is accurate. Right. So that's the fun with scalar functions is if there's no code comment about what it's used for, check and see if the results of that function are already persisted somewhere in the database, because running them can be so tricksy. Question 5. For this one, we want to write a function. We want to write a query using the function and then write the equivalent query not using the function. So this is practice, writing functions and then seeing, okay, if I wasn't going to write a function, how would I get this done? For this one, part 1, we want to write a scalar UDF. A scalar function returns one value, and we're going to name it invoice count. We want to take in an integer parameter for customer ID, and we want to return an integer. So when we're writing a function, we say, create or alter function, and then we declare, okay, what's the name of it? And then what are we taking in? So this first bit of here's the name, here's the parameter, and here's what it returns, that actually defines the header of our scalar UDF. We tell it what is the data type of what are you going to return. We want it to count the number of invoices in the sales.invoices table for that customer ID and return that count. So it requires that we do this begin end in the function definition. And inside there, we declare a variable. We set that variable based on a query of sales.invoices. So we set a filter for the customer ID, right? It's saying only for the customer ID that we passed in at the top. But we're going to do a count star, and then we're going to assign the result to this variable. So to assign the results, this is what's called a local variable. I am declaring the variable inside the body of this function. To assign a value to it, I say select, then the variable name equals the thing I'm going to assign to it. In this case, it's a count star. I then can say, okay, I want to return invoice count. So this is kind of a basic user-defined function that takes in something, says what it's going to return, does some work, and then returns that thing it figures out. If we want to use this in a query, that's part 2. Write a query that references the function, and we want to use the sales.customer table along with invoice count. We're going to return 10 rows based on the invoice count for that customer ID using the function. And we're going to return customer name and invoice count. So for every row in the sales.customer table, we are going to count how many invoices do they have with the function and return just their name and that count. I think there's also, I added an order by to the sample answer, but I didn't actually, no, we did the top 10 rows based on the invoice count. I should have been more explicit in that. I should have said top 10 rows based on the highest invoice counts. So it was a little unclear there. So you could, like in my query, I do order by the function of the customer ID descending If you did ascending, you're not wrong because I didn't specify top 10 based on what. Right? So either one could be correct. But in this case, we're using the function to return the invoice count here in the select item, and we're doing it in the order by. You could also, if you wanted to, because of that logical processing, if you wanted to write this with invoice count here, descending, right? If you wanted to do that, that would also work because the order by is processed later in the query processing, so we can refer to that column name later on if we want. That is equally correct. You can either specify the function there or specify the column name. So that's what that looks like. Let's do a little explain on this and see here is where it's calling down out to the function. Oh, this is just the return. So this right here is where it's calling down out to the function. And now I realized what was confusing me earlier. In estimated plan, the one that I just ran where I didn't run the query, in lower versions of SQL, in this one you will see the function call explicitly. If you do actual plan, I just did Control M to run the actual plan. Notice how the function disappears in lower versions of SQL. So if let's for funsies go ahead and do this against SQL Server 2019. They're both fast. Like this is not slow against SQL. This is 0.00014. I just want to compare the execution plans against 2019 to see if it inlines it. Or actually, this is the one I should time. So that's 0.010 is what that takes. So let's copy this logic over here just for funsies because I'm a nerd. We'll run this against SQL Server 2019. And it's mad because I don't have a go before it. It wants it to be the first statement in the batch, but I just highlighted it so it doesn't run anything before. So I created the function and now doing Control M. Wow, yeah, it has changed that actual execution plan and brought in the logic of that function there. If I just do Control E, executing it without the plan right, I wouldn't actually say this is, when we're at this level of discrepancy, I actually wouldn't say one is slower and one is faster, just because it actually could be the time, it could be the timing on like communication between Azure Data Studio and the engine that's the difference, just a luck thing. So that's so granular, I wouldn't say one is faster or slower. The interesting thing is that it's able to actually inline that into the plan like it is, right? So here's the estimated plan on 2019. The actual plan is different, right? So the estimated plan still shows the 2017 behavior. When you actually run it, it is actually doing something different. But for the complex one, notice it wasn't faster here. It actually looked slower. So I just think it's fascinating. All right, comparing this to, like, do we need a function for this? Well, not really, right? We could just run like this query using the function. Yes, this is a simpler query, right? There's not a join in it. So a business user might be able to understand this one a little better. However, this second one is definitely also quite a simple query. And if we can just write this one, we're generally better off doing it. We really just did this one for practice writing functions. Similarly, for this one, we're also going to write a function, write a query using the function, and then write a query that is equivalent that doesn't use the function. And this time we are going to write a function that is more complex, that determines what initials are. We're going to pass in a full name, which is in char 100, and return a char 4. And these data types are simply based upon data types in existing wide world importers tables. We're going to create the function with schema binding. And one thing to know about this is we're creating a function that does not do data access. If you do need to write functions, and by data access, I mean it's going to figure out what the initials are, and it doesn't have to go query a table, right? We are going to pass in the full name, which is, a variable character thing. It doesn't have to go join to a table. It can just figure out the thing based on manipulating the strings. In SQL Server, if you need to create scalar functions, if they aren't going to query from a table, if they're just going to do logical operations like operations on a string or operations on a date, it is recommended that you create the function with schema binding, which is a little weird if you think about it, because what schema would it bind? It's not querying a table. it can give some performance improvements because of that. The reasons it gives the performance improvements are incredibly complicated, and there's some really good blog posts on the internet. The main thing is just if you write a function and it doesn't query a table, try to remember to place a with schema binding note in the header. It's not actually going to bind any schema because look, there's no table name in here, right? There's no from, there's no join. We're just operating on the strings we pass in. So that can help performance in some situations. So it's just a best practice to do it. So we're going to determine the initials and return them in a given format. And then in the question, I mentioned built-in functions to return. And you can keep this simple, right? This could get really complicated. So just to simplify it, I gave some simple rules there. All right, so what is a function? This is a first version of a function. Like if I was going to write this in a very verbose way, I could write the function like this, where I declare two variables. I select, one is for the first letter, so I figure out what the first letter is using the left, and then I figure out what the second letter is using substring and character index. So find the index of the space in there and then move ahead one. And then I want the portion of the string. I want one bit of the string from after the space onward. Right? It's kind of awkward to think through, but it works. And then here I want to return this. So this works. This, it works. It's not the simplest thing to read though, right? You're looking at this and you're like, we can write this in a simpler way. So this is not incorrect, but we're doing this in a fairly complicated way where we have to do 1, 2, 3 different things, which makes, it's not a surprise we have to do 1, 2, 3 things. We do 1, 2, 3 things. We do 3 things. We could make this simpler if we wanted, where we could combine first letter and second letter into a single assignment string. So in this one, right, we did 2 select operations. I could do 1 select operation and figure these out in one statement here. So that would be a little simpler just in terms of readability has gone up, I think, because it's less to take in, right? This still works. And if we look at the estimated plan, right? Okay, we're doing assign and a return, 1, 2 things, right? That makes sense. But we could also write this in an even simpler way. So this way, we are saying, same headers, right? Same name, takes in the same variable, returns char4, using with schema binding because we're not reading from a table. But you actually don't have to do a select or a set in the function. You don't have to, and this is a good thing to know about functions, you don't have to declare variables in scalar functions at all. If you can write your logic in only a return statement, you totally can. So I can just say, I don't want to declare any variables at all. I just want to return, and this is the same logic I had in the previous steps. So this is, I think, I have to figure out these 2 lines, but I would have to figure out these 2 lines in any version of this code. So it's not, I don't want to say that this is like Perl, where the challenge is to write the shortest statement possible. And if you love Perl, please don't at me. I'm sorry. But sometimes, especially with scalar UDFs, like you can find them that are really verbose and they actually could be expressed quite simply. And part of the misunderstanding is sometimes people think you have to declare a variable and return the variable. You don't have to do that. You can just return the result of a calculation. That's totally fine. So I'm going to create this and then go ahead and run this, right? And that works. And if I look at the estimated plan, right, it only has to go out and do one thing, right? But it is still doing, it's not inlining this on SQL Server 2017. I could, of course, just put this logic into a query, same logic, right? Concatenation right there. And, that returns the same value. So that part of the query where you write it as another plan is right there. And of course, the plan for this, it doesn't have to call a function. It does this work in a compute scalar. So if I compare these two, the one with the function and the one without the function, to get them in the same window in Azure Data Studio, I need to remove the go to show both plans. Right? It's not like the one with the scalar function is going to be massively slower here. It just has a slightly, it's still doing this for the compute scalar for every row. It's just slightly more complicated query. Our estimated cost is generally the same for them, right? So, but I do think in this case, putting it in a function, like I'm not saying that's bad. Yeah, it's slightly more complicated plan, but if you have a business user, does your business, like if you have people who need to write queries against your database who aren't like SQL Server specialists, are they going to remember this? They can probably remember initials, full name. So there's pros and cons to using functions, and I don't want to say like never. There's reasons we use them. The more efficient you can make them, the better. And if you can leverage 2019 and try to tune your queries there, I mean, the benefit of functions in general is making your code reusable, which is why we're going to talk about more functions. So this kind of function is more fun. So we are going to demo table valued functions in SQL Server. And this one I actually no longer need SQL Server 2019 for this demo because the table valued functions in SQL Server can scale well, depending on how you write them. There are some gotchas, but these can actually scale well from 2005 on up. You don't need the latest, greatest version of SQL Server to be able to enjoy a table valued function. So we're going to set up some sample data. This is the same data that we used last time where we have a table with dog names, a table with job names, and then a table that explains what dogs have what jobs. So we use this same, here is the doggos with jobos normalized table. It's not very meaningful. So what we're going to do in the demo is compare how to write something as a user-defined function versus how to write something as a single statement table-valued function. Not every user-defined function can be written as a single value table-defined function, but many can. So this is a useful thing to know. This is one of the user-defined functions we looked at from last week. It takes a job ID in, and it returns the job name. Right? Now, as I just mentioned, this could be written more simply. So this could be written as, right? We don't actually have to declare the variable. We could actually say, I think, would this work? Return, I do need a select. From this one, because we're doing data access, yeah, I can't just do that. I do need the variables in this one. If we weren't doing data access, I wouldn't need the variable. But in this case, I am doing data access. Yeah, so that's the one we're comparing against. I could write this as a single statement table valued function. For a table valued function, the difference is it returns table. It doesn't return one value. When it returns one value, we just say, what is the data type of the value it returns in the return statement? In this one, we're saying it returns a table. And that table, in this case, it's going to have one column, but it could have multiple columns and it could have multiple rows, right? It's a table. So what we're saying here is what we're going to return is select the job name from the jobos table where the job ID equals the job ID passed in. The only reason this isn't going to return multiple rows is if we know for sure that this table will only have one row for a given job ID. We do actually know that because when we created, let's see, let me make sure I know which table it is. When we created the jobos table, let's go up and look at the jobos table, and you could look at this with SP help. The jobos table has a constraint on it, a primary key clustered on the job ID. And what a primary key means is for whatever column or columns are in here, they must be unique. Like you cannot have duplicate job IDs in this table. Every job ID is going to have to be unique. And in fact, we have an identity property on the column, meaning it's going to have like an automatically incrementing integer here. So it'll have row 1, row 2, row 3. We can determine where we want to start. Actually, we could start at negative 2,468,000, whatever int values allow. Most people start at 0. So we know that there's not going to be any duplicate job IDs in there. So this table valued function, just because we know that's unique, we know this is only going to return one row and it's only going to return one column because we're only asking for one column. So in other words, it's only returning one value. even though it's written as something that returns a table. So this has a different name. The one that's a scalar function, I have named DBO, job ID to jobO. The one that is a single statement table valued function, meaning there is only one statement in here. There are not two select statements. It's not declaring variables, anything like that. Like return doesn't count as a statement. Oh, and now I'm like, maybe I could do, yeah, I can't help myself. Let's check. This should work, right? It's going to work. Is it going to work? It's not going to let me do it. Oh, well, I can't refer to a variable that doesn't. No. Yes. It's not a table valued function, so it can't do it. Oh, cruel world. Cruel world. You know, I always want things to work that don't necessarily work. And the fact that I tried, I'm sure I tried this once in the past and it didn't work, but I hope springs eternal, right? Anyway, for our table valued function, it is a single statement one. All right, now similarly, we had another function from last week that took a dog ID, returned a dog name. We have similarly, we're going to create that function as well as one that does it with a single statement. And similarly for the doggos table, there's also a primary key on that one so that we know that any dog ID, there's only going to ever be one row for a dog ID in that table. In other words, we know this is always going to return one row and one value. Well, let's compare using these. Here is what a query looks like if we write it with a scalar user-defined function. And this is one of the confusing things about functions is how you use scalar functions, those ones that always return one value. The way you write it in TSQL is a little different than the way you write a table valued function, which can potentially, it can return multiple columns and multiple rows. You have to treat a table valued function like a table. So for a scalar UDF, this is the syntax if we want to return, the dog name and the job name while using the functions, right? We want to see what is, given a dog whose name is Mr., is the name and what jobs does Mr. have? So Mr. has 3 jobs. If I try to use the same syntax with a table valued function, notice I get all these red lines in here. And it's like, I can't do that. This doesn't, I can't just swap in the name of the table valued function. Even though I know it's going to return one value, SQL Server doesn't let me use it in the syntax in the same way. It's like, I don't see that. It's looking for a scalar function and it can't find it because this is not a scalar function. There's a couple different syntaxes I can use. And here's one. This syntax is awkward. There is a better syntax than this, but this syntax does work. We could have subqueries in our select that read from the function and pass in the dog ID for the row, the job ID for the row, and then also put it in the predicate. Right? If I run this, it does work. It does give me the correct results, but like this syntax is not going to make sense to, I look at this and I'm like, why would you do that? There is a better way to do this. So this is not common syntax. Stepping back a little bit, this is an example of if we weren't using a function at all, this is how we would write this query. We would look at the table that contains like the normalized, the ID for the dog, the ID for the job assigned to the dog. And we would join it to the table that has the dog names and the table that has the job names. We would return the dog name and the job name, and we would put, a predicate there. So if we were to do this without a function, here's what the query would look like. That's actually, if you're going to use a table valued function, the way I start thinking about them isn't like, don't look at like a user defined function. Look at, okay, how would I arrange this query thinking in sets, thinking about joining tables together, and then think about the table that the function returns, because you can use this syntax called cross apply, which is a bit like what cross apply does is it lets you essentially create a kind of join to a table valued function. So what I've done here is I've said cross apply, and then inside parentheses, I've said I want to return a little mini table like this. And notice that it is correlated. What my doggos with jobos table, I've aliased as DWJ. I'm saying I want to return the dog names from the function for the dog ID on that row. And then similarly, I want to return the job name from that function for the job ID on that row. And I'm treating it like a data set that I'm joining to. This syntax is actually quite normalized because a lot of SQL Server's dynamic management views, if you look at like sample queries for how do you use things like there's a dynamic management view you can use to tell, what indexes are fragmented. A lot of those dynamic management views use table valued functions that you can query and you can you cross apply to them. So you'll actually see this pattern often in a lot of Microsoft's documentation on for DBAs, which is quite interesting. So if I run this one, I get the correct answers. Now, in this case, I do think, the cross-apply syntax, which of these syntaxes is more readable? The one with cross-apply syntax or the one that's just doing the joins? Well, I think the one just doing the joins is more readable, and it tends to be what I would write. But the more complex your logic gets, or the more joins you kind of have in the logic you want to reuse, sometimes things change, and this does become simpler. And one of the really interesting things about this is SQL Server is able to handle these really efficiently. I'm going to look at both of these, and I'm going to compare the execution plans. And I think this is really quite interesting. The query that just has joins and the query with the cross applies are actually rewritten in exactly the same way. So the estimate cost 0.010198, 0.010198. Yeah, that was the same, right? So these are interestingly recognized as being functional equivalents in this case. Now there is also an outer apply. So cross apply is like an inner join. An outer apply is like a left join, right? It's more common to use cross apply than outer apply. I'd say first just worry about cross apply. And I will also say that there are more uses for cross apply than only functions. Cross apply, they are commonly used with table valued functions, but you can use them in other ways too. And there's some cool patterns with them in terms of tips and tricks for TSQL as you keep learning. It's one of the fun topics to delve into kind of as you keep advancing with TSQL. So a couple links here to dig into in terms of how cross-apply works. Another example here. So we can also use cross-apply if we want to group data. So here I'm saying I want to use cross-apply, and I'm aliasing the results of the cross-apply as J. So what I'm doing here is I am querying the doggos with jobos tables. And for every row in doggos with jobos, I am saying, okay, I want to figure out what the job name is from this table valued function for that job ID. The data that's returned from this cross apply, I'm aliasing it as J. So J.jobo right here is coming out of the cross apply. I can group by that, just like if I joined to a table, I could group by a column in that table. I can join to a column, or I can group by a column coming out of a cross apply. And that query is runnable as well. So here we're looking at all of the jobs and the count of the number of dogs who have that job. So we have 2 dogs who are best friends. Right? So that's one way we can write that. Now, an important thing to know is that single statement table valued functions are inlineable. Multi-statement ones are more like user defined functions. So in other words, you can, for scalability, if you can get all of your logic into one thing that is being returned in the table valued function, it will be better than if you have multiple statements. And this is oftentimes just something people aren't aware of. So the multi-statement one, notice this one has been written with this syntax. Returns my table, this is a table variable, which is a table, and the table has this many columns in it. This syntax would actually seem to be better, right? If you looked at these syntax regardless of anything else, I would say, oh, well, this syntax is probably better because it tells you right up front exactly what it's going to return, including being explicit about the data type. That seems really good. But it's not actually better for SQL Server. It looks better, but it's not, because by having to declare a table variable and then insert stuff into it and then return, this becomes a multi-statement table valued function, and it actually cannot enjoy many of the performance benefits of just return a thing that maybe I haven't even defined the data type in it. So I know that seems backwards. The thing to remember is when you're designing functions, try to keep the code as simple as possible, and do not, if you're using table valued functions, do prefer the patterns that just say return table. Don't actually define a table variable in the header and then populate it and then return it, which I know seems backwards, but it's just one of those things. So I'm going to create both of these functions. This one is table valued function. This one is multi-statement table valued function. And then if we compare and contrast the execution plans for these, I'll just do a little explain here. Here is the first one, right? One complicated execution plan. Here is the second one, or wait, sorry. The first one is the multi-statement table valued function. So we've got one branch here, then we're going down, we're calling the function here, right? More complicated plan. The one where it is a single statement table valued function, it is actually able to generate a simpler plan. Now again, inlineable is often something that performs better, but it's not guaranteed. So fun thing with performance tuning is there's always exceptions when the thing that should perform better or might perform better just doesn't. So it's a thing to know. It generally, in the case of table valued functions, single statement ones generally perform better. There's always an exception to the rule though. And that is what means we still have job stability, I guess. There's plenty of jobs in the database space. So if we wanted to just run a query, of course, and not use any function at all, we could do so. So this is a little tour of table valued functions. Homework tonight, or this week rather, is all about writing table valued functions. And I think these are really, really fun. I think figuring out when you want to make code reusable, often the tools I would lean towards are table valued functions, especially single statement ones, really, really useful for reusable code. And then stored procedures, which we'll talk about later, really, really useful for reusable code as well. All right, well, that is class for today. So I hope that you enjoy the challenges, and I will be back next week to talk about more TSQL for beginners. Thanks for joining me, folks. I am Kendra Little from Redgate, and I'll see you again soon.